What we're going to do is we're actually only going to roll through the second equation because the first one's kind of easy, I think. So the second equation was $2.50 per what?
$2.50 per game, and then rides were $1.
For a total of $15, right?
Yeah.
So one thing I like to do to get organized is I write x equals games, y equals rides, just to keep it straight. In fact, if I was going to make this equation and it wasn't given to me, I'd probably do 2.5g plus r. I like using variables that just help me keep things straight. So games are going to go along the x, rides are going to go along the y. It's already labeled for us. And so if they only go and do games, so only x, how many games can they do? 6 games. And I get there by, and here's why 6 works. Would you agree 6 games is 0.60?
Yes.
Which means when y is 0, if y is 0, 2x, 2.5x plus 0 is 15, you would just divide by 2.5. You don't need to mess with that 0. So you guys did this intuitively. I'm just showing you that when y is 0, x is 6. I'm just making a connection there. You guys used intuition. That's the whole point of this. Now, if I go on rides, only how many rides? 15. Okay? Bring a deck of cards. Play your own games. Go on 15 rides, maybe. Okay, hack the system. And the reason this works is this point is 0, 15. Okay? When x is 0, y should be 15. Well, check it out. When x is 0, what's 2.5 times 0? 0. So when x is 0, what does y have to equal? 0. It works in the equation. These points satisfy the situation, right? Yes, Evan, for clarification. We're only going to do the second one. The first one's kind of same thing, only easier. So I'm choosing to go over the second one altogether. And then it says connect the dots. I'm going to try to draw a straight line. Okay, that was pretty good. And then, what's the next question it asks? Micah.
It says, what is the slope of your graph after? Well, it depends because complete the sentences, but if you want to skip that, then...
No, let's complete. I want to complete the sentences. I just don't want to go back and forth
complete
between.
the sentence. If the student plays no games, they can get on 15 rides in this situation.
Yep, 15 rides.
For every additional game that the student plays, X, the possible number of rides, Y, decreases by 3 because it's 2.5.
So check this out. As X increases, Y decreases. So, if you play one less game, how many rides can you do?
3 less rides?
No, it's 2.5.
2.5.
Yeah.
Well, 2.5.
Which is kind of tricky because you probably can't do a half a game.
Right.
But, okay. So here's what we're going to look at now. We're going to look at making the equation say that relationship. So right now the equation says these two things together total $15. You just referenced the ride. What does the ride equal to? And you said it's going down $2.50 per game. So check this out. $2.50 per game, that's minus 2.5 for a slope, right? You guys remember slope from last year?
Yeah.
Okay. So, yep. And if we go down 2.5, right 1. So down 2.5, right 1, we're going to end back on the line over and over. But watch this. We're going to make a connection from yesterday. If I have 2.5x plus y equals 15, and I want to isolate rides, how do I get rid of the games?
Minus Y.
Minus 2.5x. So y is equal to the 15 minus 2.5x. And here's what this means. This means the number of rides is equal to the $15 minus the price for all the games, which you just did with that 2.5 less. It's all right there in an equivalent equation that we used. Same thing to both sides to make. What's important that we need to point out is this number right here is the slope. Is that down 2.5 each time? Right here is our starting point. That is called the y-intercept or the vertical intercept. Okay. Now I know you saw this stuff last year and it's been like a minute. That's why but what I want you to focus on is these connections. What's true about this equation and this equation?
They're the same.
Same's equivalent. We proved it in 2 ways. Used intuition for your situation to answer those questions. And we proved it by doing the same thing to both sides. And we proved that it is this graph. Now, we made a solid line. Are there technically infinite answers for this?
Yeah.
Theoretically, yes, but can you buy partial games or partial rides, you think?
I mean, hey, they could have you put on the ride. You could go up halfway and they say, "Oh, get off," and then you.
Yeah, just yeet off the Ferris wheel once you get to the top and pay half. I don't think it's going to work like that. I don't think it's going to work like that.
Maybe it's literally there.
A summary of these things we're looking at. There's going to be multiple forms of lines. This is one of them, standard form. What do you notice about the variables in standard form?
There's a lot.
Well, no, there's two.
A, X,
They're added.
So we've seen these like 2x plus 4y equals 20. How many variables are there? Two. What do you notice about their location?
X is first, Y is second, just like on the graph.
Okay, that's true. Same side. So this is important. We've seen this equation a bunch of times. Cars and trucks, almonds and figs, miles and people. All these different situations we've been working with. A lot of those are standard form. But when we got things changed to like trucks only, what was true about the variables? Like yesterday, the trucks only. It was like trucks equaled whatever, 21,600 minus 3.6c over 7.5. Are variables on the same side from the truck one yesterday?
Yes.
These are on the same side?
Oh, no.
So those are on different sides. When it was standard form, trucks and cars together, standard. So when they're on different sides, there is something else called slope-intercept form, where we have the slope and the y-intercept. So you've been seeing these things already. So now we're going to make the connection to the graphs. And these have strengths for the graphs. The strength of standard form is finding intercepts. And here's why. Just stay with me. Let's say there's different prices. Let's say it's $2 per game and $4 per ride, and you have $20. How many games can you do? 10. How many rides can you do?
5.
And we can just look at that and get those intercepts, right? And it's because when y is 0, 2x is 20. When x is 0, 4y is 20, right? This form is really good for intercepts. And let me show you how you know that. The other form of this is y equals negative 1/2 x plus 10. This is good for the one intercept, the y-intercept, right? Right there, it's still 10, right? 20 divided by 2, it's right there, 10. Is this one good for the x-intercept? No, to get the x-intercept happens when what? When y equals what? 0. So to get the x-intercept from this, you'd have to do this. And if you do this, to get x alone, you got to do stuff, right? Yeah. So this is not great for x-intercept. So standard form is great for intercepts. What slope-intercept is great for is seeing a starting point of something. So starting at the 10 rides. And then what happens with each additional. Okay. So how it's changing. So slope and y-intercept. So we're going to practice. This is the first time we've seen it. We're going to practice like when we have these different forms, what's the best way to use them. We also have rate of change. You're going to hear me call it slope most of the time. Okay? And that explains how a line's changing. You guys remember slope, dude? Puff, puff, positive. This is 0 fun. Nice. Negative. Undefined. Yeah, slope dude's a legend. The worst word in math. And then we have a vertical intercept. You're always going to hear me call it the y-intercept pretty much, but it is the vertical line's intercept. And that's usually a starting point in a situation. We already know this. So we're going to work on these nickels and dimes next. Andre straight rich. He got 85 cents. And it's only nickels and dimes because his parents steals the quarters for shopping carts at Aldi, okay? So you're going to find combinations of nickels and dimes in this jar on the back of your notes page with your partner. I'm going to give you 2 minutes. It's going to go quick. So when we're doing this nickels and dimes, there's 2 equations I would consider. I would think 5 cents per nickel plus 10 cents per dime equals 85 cents. Or 5 cents per nickel, 10 cents per dime equals 85 cents. These will both work because the graph is numbers of nickels and dimes, right? Number of nickels. Oh, I forgot the letters. Okay, I got it. And you could have labeled your axis different. That's the thing that could happen. So if I want all nickels, I can get, that's not the spot, 17 nickels, right? If I go all dimes, 8.5, which we know there's not 8.5, okay? But this is like theoretical. Also, I think we know the situation would not be continuous. It would actually be discrete. There's not partial dimes and partial nickels. We would only have these very specific combinations of nickels and dimes that work. Yeah. Yeah. So this is theoretical, right? We were talking about this, Em and I. We can't have a half, right? So how many nickels in the jar of no dimes? 17. How many dimes? 8.5 theoretically. But you can't. Okay? You actually can't so this is why a graph's great, but without context, not great. The context helps us. Yeah.
Other sort of a question like this, we put 8.5, will we get more of this wrong?
Yeah, unless you said if you said theoretically 8.5. Yeah. A lot of times it's the explanation that makes you right or wrong in that thing where we need to talk about context. Bob, this isn't on there, but I want to look at this. What form is this? Standard or y-intercept? Slope-intercept. Yeah, standard. So we can get standard to be slope-intercept every time. So number of dimes is my y, so I'm going to subtract 5n. 10d equals negative 5n plus 85. This is from our warm-up today. So the number of dimes is equal to negative 1/2 for each nickel, right? Plus 8.5. Well, here's that theoretical 8.5 starting point. And why is it going down 1/2 for each nickel? Well, nickel's worth how much of each dime? Half. So these are the same. This would be only in relationship to dimes. This one is in relationship to total. But because we did the same thing to both sides, slope intercept form is equivalent to the standard form. Which one would you rather find intercepts from?
The first one.
Yeah, the first one. You can just divide by 10, divide by 5. This one tells you the relationship between the two a little bit more, okay? We're going to keep working on benefits, pros, cons, strengths, weaknesses with these as we keep going. Here's what we were talking about with that discrete relationship. We don't need to do any more on that, okay? You're going to cool it down with your lesson summary. I'm going to hand out your homework, but you do need to do your lesson summary first, all right?